Hi Ben, you're just back from watching a musical? Which one?
Oh, Willy.
You just saw Ur Wully?
What was your favourite song?
Willy, Willy Wagon, Willy, Willy Wagon, you're too hee-ho.
It's time for Maths with Mr. Thomas.
Yes it is, Grace, thank you very much. This is lesson 7 of the Trigonometry and Bearings chapter, and it's the third lesson looking at the sine rule. We have used the sine rule to work out the length of a side, we've used the sine rule to find the size of an angle, and now we're moving on to look at finding an obtuse angle using the sine rule, which I've called ambiguous cases. Ooh, Nick, what is your question? What does ambiguous mean? Good question, Nick. Well, if a question has more than one correct answer, it is said to be ambiguous. For example, if I gave you this picture here, do you see in this picture Mr. Smith or do you see Mrs. Smith? Is it an old man or is it a young woman? Well, both are correct within this. There's the eyes of the old man, there's his nose and there's his moustache, but it could also be a young woman. There's her eye, her nose, her face is over here, she's looking out this way, and that is her hair. Both answers are correct. There is both an old man and a young woman within this picture, so it's an ambiguous question. It's an ambiguous case, and as it says here, questions involving the sine rule are often ambiguous, and the reason for this is because if I asked you to find the value of x for which sine x equals 0.5, well, there's actually two answers. If you work out the sine of 30 degrees, you end up with 0.5, but also if you work out the sine of 150, you also get 0.5. And the reason is because if you look at the sine graph, which you'll look at later on in the trig graphs chapter, you don't really need to know this bit just yet. If you follow the sine graph to 30 degrees and you go up, then on the y-axis you're at 0.5. But also, if you go along to 150 degrees and you go up to the sine graph and you go straight along, that is also going to give you an answer of 0.5. But it's not just sine 30 and sine 150 that would be the same. You get lots and lots and lots of pairs. As it says here, it is true for other angles. The sine of 10 degrees is also the exact same as the sine of 170 degrees. Again, you can show that just on the diagram. The sine of 10 degrees coming along, if you go up, and the sine of 170 degrees, you can see they would be about the same. It's going to be the same for a sine of 25 degrees and sine 155. Again, if you look back to this diagram, find 25 degrees, find 155 degrees, and they are the same. If you look at sine of 80 and sine 100, again, there's a diagram, find 80 degrees, find 100 degrees. You can even see it here with 60 degrees there, 120 degrees there. Both of them are giving you the same answer. Has anybody managed to work out the link though? What is the link with them? Colin, I see you waving like a maniac. Tell us. Well, if you do the sine of an angle and then sine of 180 take away that angle, it's the same. Well done, Colin. You are perfectly right, which means the sine of an angle, let's just call it angle x, is the exact same as sine of 180. Take away that angle, which you can see here. The sine of 30 is the same as sine of 150. And 150 is 180 take away 30. If you do the sine of 10, well, 180 take away 10 is 170. So the sine of 10 and the sine of 170 will be the same. The sine of 25 and the sine of 155, they are the same. Which means then it becomes awkward when we're working out the size of an angle in a triangle, because if we were working out the size of an angle in these triangles, or we set up our sine rule, then we can say, well, there's a pair, there's the 3 and the 10 degrees, that's going to be the same as the 9 and then the 31, so we can say 3 over sine 10 is equal to 9 over sine 31. But also, we can see the 3 over sine 10 could also be equal to, well, if we redrew that triangle, keep this length as 9 centimeters. I'm just kind of zooming in by this triangle here, but imagine if that was still 9, if that length was still 3, well, this angle here is not 31 anymore, it's 149. So really, we would end up with two answers. And if we rearrange that the way we did in the last lesson to actually find the angle, well, how do we know which one it's going to be? if we've got sine of something over 9 equals sine of 10 over 3. We don't know what that angle is going to be. We don't know if it's 31 degrees or 149. However, if you look at the question's either going to have a diagram, and in the diagram, if you can see that it is going to be an acute angle, well, the calculator should give you the acute angle when you do shift sine equals. But if it is an obtuse angle, what do you then do if it's an obtuse angle you're wanting to find, Neil? You would take your answer away from 180. Well done, Neil, you're right. You would indeed. If it's an acute answer, just keep it just the way we did in the last lesson. But if you're asked for the obtuse angle, subtract your answer from 180 degrees. Want to try some examples? Oh, yes, please. Then let's go. Example 1. Calculate the size of the obtuse angle ABC. So going from A to B to C, we're wanting the size of this angle. Because it is an angle we are wanting to find, and we know it's to do with pairs, we know it's to do with the sine rule, we are going to be putting the angles on top. Remember, in our formula, the capital letters represent angles, so the capital letters go on top with sine A, sine B, sine C, and the lowercase letters, the A, the B, and the C, are going to be the sides. How do we start off a sine rule question? What do? You start with what you want to find. You do indeed start with what you want to find, and here we're wanting to find out this angle here, which is labelled x. So we would say sine x over, and it would be sine x over what? 14. It would be 14. Good. So sine x over 14 would equal, what is the other pair? Remember the angles this time, because we want to find an angle. The angle's going on top, and the side at the bottom. Good. That's the other pair. We've got 23 degrees there, 8 meters there. So we will have sine 23 over 8. Good. We want to get sine x just on its own, so we're getting rid of the divide by 14. To do that, multiply the left-hand side by 14. That will cancel out divide by 14, leaving you with sine x. But the other side, we want to times that by 14. Because you're multiplying, put the 14 on the top, but put it in front of the 23. Don't do sine 23 times 14, otherwise the calculator might do 23 times 14 and take the sine of that, which we don't want. We just want 14 times by whatever sine 23 is. So 14 times by sine 23, and then you divide that by 8. If you work that out on the calculator, beep, 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 you get 0.68377, blah, 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 to quite a few decimal places. We are not wanting sine x, though. We are wanting x. So how do you go about going from sine x to x? You do the inverse sign. You do indeed, yeah. So sine to the minus 1 of the 0.68377. Just keep that answer in the calculator. Do shift sine equals or shift sine answer equals, whichever way it works on your calculator. And you end up with 43.14 degrees. Woo! Chloe, you don't look happy. What is the matter, Chloe?
I don't think that's the right answer.
Why do you not think that's the right answer?
Because it's asking you for the obtuse angle.
You are indeed. Well done, Chloe. So, Chloe, what do you do?
Well, we know that angle X, or ABC, is not 43.14 degrees. That's just silly. So you have to take that away from 180 degrees.
You do indeed. Well done, Chloe, because it says here sine of an angle is the same as sine of 180. Take away that angle. So if you do 180, take away that angle, that would also still work out for this question. So all we're wanting to do then is say that since ABC is obtuse, then we know that ABC must be 180. Take away the 43.14. And if you work that out, you don't even need a calculator to do that, you will end up with 136.86 degrees. Are you happy now, Chloe?
Oh, yes, I am.
Well done. Okay, shall we try another one?
Oh, yes, please.
Example 2. Calculate the size of the obtuse angle FGH. FGH. There's F to G to H. We can see it is this angle here we are wanting to find. And again, there is a little X just here, just in the corner. So how do we start this off? What do? Well, we always start with what we want to find. You do indeed, yes. We're starting with what we want to find. We want to find this angle. Because it is a sine rule question, we are going to be using the sine rule. So we're thinking about our pairs, but because we're wanting to find x, start with that. What is x paired up with?
600.
It is paired up with 600. Yes, well done, Freya. So, how would you write that out? Good, because this is an angle you're wanting to find, the angle's going to go on top. And the angle is always paired up with sine. It's always sine of the angle in the sine rule formula. So we've got sine of our angle, x, divided by 600. And that would be equal to, what is our other pair? Good, our other pair is 40 degrees. Remember, a pair is an angle and the side across from it, which is 513 meters. So we would have sine of our angle, sine 40, and divide that by 513. Woo! From there, we're wanting just to get sine x. So how do we go about getting sine x just on its own? Freddy? Good, you can multiply by 600. Excellent. So if you multiply by 600, it gets rid of divide by 600. But again, you'd have to multiply the other side by 600. Because you're multiplying, put it on the top, but again, same as the other questions, put it in front of sine 40. So it's 600 times by whatever sine 40 is. And you're dividing that still by 513. Are you ready? Calculators at the ready. Beep, 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 beep. You end up with 0.75179, blah, 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 blah. And from there, what would you do? Good, you don't want sine x, you just want x. So just to get x on its own, you would have to do the inverse sign of that answer. So shift sign answer equals, shift sign equals, whichever way it works for you. And you end up getting 48.75 degrees for that massive angle there. What are you thinking though? Ooh, Jammy Jamie, help us out. Give us your words of wisdom.
Well, there's no way that that big angle that's clearly bigger than 90 is just 48 degrees, because 48's less than 90, and that's mental. What I'd have to do with that is I'd have to do, gee, help me out.
Well, you'd have to do 180 to take away the angle.
Oh, aye, so you would, that's perfectly right, which means then you could say that the angle is obtuse, and we can see that clearly from the diagram, and also if we read the bleeding question it tells you. So it means that FGH is going to be 180 degrees, take away the 48.75 degrees, and that gives you, hold on, let me work it out, that's going to be 131.25 degrees.
Thank you very much, Jamie! Said with so much enthusiasm. Thank you, Jamie, but you're perfectly right. Have a go at some of these questions. There's an exercise in the Lecky and Lecky National 5 book, page 300. Just question 3, working out the size of an obtuse angle. Give these questions a shot. Just remember, you would do sine to the -1 and get the acute angle, but then make sure you read the question or look at the diagram. Is it obtuse? Do you have to subtract it from 180? If you do, do it. It'll be worth an extra mark. It'll be worth the mark. You lose a mark if you don't. Just do it. Practice these questions. See how you get on. Good luck. Bye. Woo!